You know the scene. A storm's rolling in, the sky gets all dark and moody, and then, bam, a brilliant flash of light. And without even thinking, you start counting.
So what if I told you that in those 5 seconds, an entire epic story just played out? A story about invisible ladders, explosions that shoot up, and a sound made by something 5 times hotter than the surface of the sun. Yeah. Okay, let's get into it and figure out what is really going on between that flash and that bang.
All right, so the very first part of our story starts way up inside a storm cloud. This is where the whole thing gets its power, where the cloud basically turns itself into a giant battery.
Remember when you were a kid and you'd rub a balloon on your hair to make it stick to the wall? That friction creates static electricity. Well, just imagine that, but on an absolutely colossal scale. Inside a big old storm cloud, you've got these powerful air currents, updrafts and downdrafts, just churning everything up. Tiny ice particles and water droplets are crashing into each other millions of times a second. And all this crashing and rubbing actually separates the electrical charges. The lighter little ice crystals end up with a positive charge, and they get blasted up to the top of the cloud. At the same time, the heavier, slushy hailstones, they're called graupel, they get a negative charge and sink down toward the bottom. And so, what you're left with is this massive, polarized battery just hanging out in the sky. You've got a positive top, a negative bottom, and this creates a huge electrical difference between the cloud and the ground below it. All that pent-up energy, well, it has to go somewhere, right? Okay, so the battery is charged and ready to go. But how does that electricity actually jump across miles of air to get to the ground? Well, this next part is pretty wild, and it's something we can't even see happen.
So, coming from that negatively charged bottom of the cloud, a little channel of energy called a stepped leader starts to feel its way down. And it doesn't just go in a straight line. Nope, it zigzags, moving in these short, jerky steps, kind of searching for the easiest path through the air.
Now, check this out. As this super powerful negative charge gets closer and closer to the Earth, it starts affecting the ground itself. It actually pushes away negative charges on the surface and pulls all the positive charges up. You get these positive charges surging up through the tallest things around, trees, skyscrapers, you name it. So you have these two parts of the puzzle about to connect. You've got the negative stepped leader coming down and these positive upward streamers reaching up from the ground to meet it. And when they finally connect, usually a few hundred feet up, the stage is set for the main event. And here it is. This is the part that will totally change how you look at lightning forever. That brilliant flash we see, it doesn't travel down, it shoots up. The second that leader and streamer connect, they create a perfect low-resistance path. And in that instant, a massive wave of electrical current, we call it the return stroke, violently rushes up that channel from the ground all the way back to the cloud. It moves at about 1/3 the speed of light. So that giant flash that lights up the whole sky, that's the energy exploding upwards. Wild, right? And the amount of energy we're talking about here is just mind-boggling. This return stroke superheats the air in that narrow channel to about 30,000 degrees Celsius. Just to put that into perspective, that is 5 times hotter than the surface of the sun. All of that heat packed into a channel that's only a few centimeters wide. And that incredible, instantaneous blast of heat is exactly what creates the sound we all know as thunder. Think about it. When you heat air that fast, it expands explosively. I mean, faster than the speed of sound. This creates an unbelievably powerful shockwave that just radiates out from the lightning bolt. And that shockwave, well, that's what we hear as thunder. It's basically a sonic boom created by lightning.
So, ever wonder why sometimes it's a sharp crack and other times it's a long, low rumble? Well, if the lightning is super close, you hear the shockwave from the whole channel at pretty much the same time, and it's a loud crack. But if the strike is far away, the sound from the bottom of the channel gets to you first, and the sound from the top gets to you last. That delay is what creates that classic, long, rolling rumble. Which brings us right back to our original question. We can actually use this delay to figure out how far away the storm is. Light travels so fast it's basically instant, but sound is much slower. It takes about 5 seconds for sound to travel 1 mile. So next time, see the flash, start counting. 1,000, 2, 1,000. Every 5 seconds you count is about 1 mile of distance. Simple as that. So that's the whole story of a classic cloud-to-ground lightning strike. But what's really cool is that this is just one type of lightning.
The sky is full of all kinds of electrical fireworks.
In fact, the most common types of lightning never even touch the ground. They just flash inside a single cloud or jump between two different clouds, lighting them up from the inside. And then you have these bizarre, almost alien-looking forms high above the storms with these amazing names. You've got sprites, elves, and blue jets, these ghostly red and blue flashes happening at the very edge of space.
And with something this powerful, of course, a few myths have popped up. You've heard it. Lightning never strikes the same place twice. Yeah, tell that to the Empire State Building, which gets zapped about 23 times every year. Or how about the idea that metal attracts lightning? Not quite. Lightning just wants the easiest, tallest path to the ground. Metal doesn't pull it in, but if it's in the way, it's a really good conductor.
So there you have it. It really is a whole story, isn't it? You've got the slow buildup of energy, the secret forging of an invisible path, this dramatic upward shooting explosion of light, and finally, the sonic boom that rolls across the sky. All of that happens in less than the blink of an eye. So the next time you see that flash and you start counting the seconds, maybe you won't just be thinking about the distance. Maybe you'll be picturing that invisible leader, that upward return stroke, and that superheated shockwave racing towards you. Pretty cool, huh? Stay curious.